Hi, welcome back. So now let's try to have an example regarding the circular disc method in finding the volume. Say for example, we have a curve, um, curve y is equal to the square root of x, and line x is equal to 2, and the x-axis. Okay, so let's try to find the volume of solid generated by this curve y is equal to square root of x, line x is equal to 2, this is 2, and the x-axis if the axis of revolution is at x-axis. Axis of revolution is at x-axis. Okay, so first thing is to draw these figures, and before we come up with the analysis, and as well as to have the label of the important data that we need, also as the representative strip or element, I mean the representative disk or element. So say we have the so you have x and y, then we need to determine the intersection of this curve and line, and as well as the x-axis. So we need the x-axis, the line 2. So let's graph first the line 2. Say this is 1, this 2. So this is x is equal to 2. So we have line x is equal to 2. Imagine that it is a straight line, huh? Then we have the x-axis. X-axis as our boundary. So this is our x-axis. And then our curve y is equal to square root of x. So in order for us to determine the intersection of this curve and the line and the x-axis, so let us solve the equation simultaneously. So if y is equal to square root of x, and then if our x is equal to 2, then let's substitute the value of our x. So we have y is equal to square root of 2. Therefore, our point of intersection between this line and our they call this curve is at our x is 2 and y is square root of 2. So we have 2 square root of 2. Then let's say this is 1, this is 2. Then the point is about, so we have 2 and then square root of 2. The square root of 2, if you gonna take the value of square root of 2, it's around 1.5 something. If I am not mistaken, it's around 1. Let me use my calculator, no? Pairam calcul. Thank you. So using my calculator, the square root of 2 is 1.4. Yan. So this is around 1.41. So if we have 2, 1.41. If this is around 1.5, so around this point is 2, and 2 square root of 2, right? Then for the intersection of x-axis and y, so if we have this line, then our y must be equal to 0. So if y is equal to 0, then our x is what? So if using our curve, so if y is equal to 0, our x is the 0 is equal to square root of x. Therefore, our x is just 0. So we have the intersection point or coordinates at 0 0. So this is our 0 0. Okay, so we can now draw the curve y is equal to square root of x, and assume that this. If you want to make your curve more accurate, then let's try to find if our x is equal to 1. So if x is equal to 1, our y is equal to square root of 1 is just 1. So we have 1, 1. This 1, 1. Okay. So we have this graph. Oops. Yan. So that is y is equal to square root of x now. Then all we need to do is to find the area, the volume by this region bounded by the x-axis, the x is equal to 2, line x is equal to 2, and the curve y is equal to square root of x. And it says here that our axis of revolution is at x-axis. So if we rotate this region around the x-axis, then our illustration will be look like this. So we have this part here, then say we have this part. Sorry. Make sure that your illustration is what they call this, symmetric to each other. So we have this curve, right? So we need to determine this v. Okay, and let's take a small strip here to represent our disk. Yan. Then applying our equation, v is equal to the integral of pi r squared d of x from a to b. So this is our, this thickness is our dx, it is our x, and then this part here is our r. Okay, or in our r here, say if this r here is our y, right? This length here is our y. So we have v is equal to the integral of pi r squared dx. So our a here is from this point, which is 0, to this point, which is 2. So from 0 to 2, our limit is from 0 to 2. Then we have our pi, and then our r is equal to y, length y, so we have y squared, and then our d of x. But our y is, what is our y? Is equal to square root of x. So we have the 0 to 2 pi square root of x squared d of x. Then if we take the square of the square root, so we have x dx, and integrating this using the definite integral, we have pi x squared all over 2 from 0 to 2. And using the definite integral, we have pi 2 squared all over 2 minus the 0, because 0 squared pi all over 2 is just 0. So we have the pi 4 all over 2, or just 2 pi. Okay, 4 divided 2 is just 2. Then we have our pi. So we have 2 pi cubic units. So the volume of the said solid is 2 pi cubic units, bounded by the curve y is equal to x, line x is equal to 2, and the x-axis, and the axis of revolution is at x-axis.